Hello, everybody, and welcome back to BioSC 140 Human Physiology. This video is for Laboratory 11 and 12 experimental procedures. So, in this lab, this is the frog lab. In this lab, we're going to be doing some really cool things with some frog specimens. Normally, this lab is our only 2 day lab. We do a practice run on the first day where we run through all of the procedures. We do everything, just we do it without our frog specimens. On the second day of the lab, we are then prepared. We know exactly what we're going to do, and we're ready to do a good job because we only get a limited number of frog specimens, and we want to make those frog specimens, we want to get the most out of their sacrifice. So in this laboratory, 11 is the dry run. We get familiarized with equipment, setup, and procedures, and we just prepare. We do a practice run so that on the 12th, when we do the real deal, we get the most out of the frog specimens that we have. So this is our frog specimen. It's the American bullfrog, Lithobates caddisbane. I'm probably saying that wrong. This is not an endangered animal. It's a very common animal out in the wild. The specimens that we normally get for lab are not wild specimens. They're specimens that were raised in a lab by Sacramento for the specific use of science. These frogs, when we get them in lab, are what's called double-pithed, which means their central nervous system has been destroyed in 2 different ways. Their brain and their spinal cord have been destroyed in a humane way. So they're technically dead, like they can't feel any pain. They have no central nervous system. They have no processing centers, no spinal cord or brain. But frogs breathe through their skin. They have diadermic breathing. They breathe through their skin. And this allows their cells to continue to get oxygen, to continue to do metabolism, to survive long after their central nervous system stops working. So if we were in live lab, we would need to keep their skin moist, as that's required for this diadermic breathing to happen. So remember, metabolism continues in their cells. The frog is dead, it feels no pain, but cellular processes are continuing in most of the cells of this frog. So step 1, normally we would choose 3 to 6 people to do the dissections on the frogs. I'm not going to have any questions on how to do the dissection, but this kind of gives you an overview of how to do the dissections and how, if we were to do it in real life, how to do it. So a few things to note. We're going to be using the sciatic nerve of the frog for this experiment. So we'll have one group of people who are doing the dissection remove the sciatic nerve. The sciatic nerve is the main, it's a large nerve that travels down your leg. You might have heard somebody say, oh, I got sciatica. I got sciatic pains from the sciatic nerve. We're going to dissect it out, and you'll see what we'll do with it in a moment. With the gastrocnemius muscle, what we're going to do is we're going to cut the Achilles tendon, pin the frog's leg down, tie a string to the Achilles tendon, and attach that to a pulley system that's going to measure how much force is generated by this muscle. After we're done with our experiment involving the sciatic nerve and our experiment involving the gastrocnemius muscle, We then open up the chest of the heart, and usually when we open it up in lab, the heart is not beating. But if you kind of do some CPR on it, you squeeze it a few times, you can actually get it to start beating again. And it's really incredible to actually watch the heart beat within the frog. And then we expose the heart to various chemicals and the sciatic nerve to various chemicals, and we see how that changes the effects. So let's see the frog setup, the frog sciatic nerve setup. So we have this chamber right here where we have where we lay the sciatic nerve. This is what the sciatic nerve looks like. It's kind of like a cream color, a long, thin cream color nerve. And we put it on this bed of pins. So our first pins are going to be, actually this pin is going to be the pin where we introduce an electric shock. We're going to shock the nerve on this pin. Up here, these two pins are the recorder pins. They're going to measure the amount of electricity, the amount of signal that has been sent through this nerve. So we shock the nerve here. That signal is then transferred through the nerve, and we record it up here on these pins. So this is about the setup that we would have. All right, perfect. The skeletal muscle setup is similar to what we saw in one of those previous slides, where really what we need to know about the setup here is right here. We're going to have the frog leg pinned down. We're going to have the Achilles tendon severed. We're going to have the gastroc still attached at the knee. We're going to tie a rope around the Achilles tendon and have that rope go to a pulley system, which is going to measure force generated. We'll then have a couple electrodes placed into the belly of the gastroc muscle, where we can shock the muscle and get it to contract. All right, it's the frog sciatic nerve. Here's the setup. We're going to administer stimulus, so we're going to shock the muscle, the nerve, and we're going to record how much electrical activity how much electricity goes through the nerve. We're going to start at a very low voltage, and we're just going to increase the voltage at specific increments. So right here, frog sciatic nerve, you can see that we start at 0.1 volts. We then go to 0.2 volts, 0.3, 0.4, 0.5, 0.6, and we steadily increase the voltage, and we see how that affects how much signal is sent through the sciatic nerve. A little bit of background information. What we're going to be doing, or what's going to be happening, actually, we'll get into that in the discussion. Let's focus on procedures here. So with the frog sciatic nerve, there's really one basic procedure once we have it all set up. Steadily increase the amount of voltage that you're shocking the sciatic nerve with, and read and record how much signal is being sent through that sciatic nerve. With the skeletal muscle, we're going to do the same procedure, but then we're going to add another step on at the end. We're going to increase our stimulus strength, so we're going to start at 0.1 volts, then 0.2, then 0.3, and so on volts. And we're going to see how that increases the amount of force generated by that muscle. After we've gone through and done and found out what shock produces the highest amount of force, once we know what shock produces the highest amount of force generated, we're then going to examine how frequency of shocks affects the amount of force generated by the frog muscle. So we're going to start with 1 shock every second. We're then going to do 2 shocks every second, 4 shocks every second, 6 shocks every second. And we're going to see how increasing the frequency of shocks, how it changes the amount of force generated by the muscle. So there's your procedures. We're going to get into the discussion next.